All right, it is 2 after, so let's begin here. So welcome everyone. This is the Redfish 2023.2 webinar. I'm Michael Ranieri from Dell Technologies. I'm one of the co-chairs of the Redfish Forum, and with me is Jeff Otter. So Jeff, say hi.
Hi, everyone. I'm Jeff Otter with Hewlett-Packard Enterprise. I'm the other co-chair of the Redfish Forum.
All right, thank you. All right, just to be aware, this webinar is being recorded, and we will be posting it publicly on the on DMTF's YouTube channel. And we have our first polling question for folks on the call. All right, so what is your interest in Redfish? We'll give it about 30 seconds for people to answer. Okay, that should be enough time for folks to answer that polling question. So let's see what the results are. Okay, so not atypical. It's yeah, we get a good number of folks working on Redfish products. Some DevOps people. Oh, RDE things. Okay, and we did see someone pick up on our joke answer. Alrighty, thank you. Okay, so we'll jump right into the material for what came out with the 2023.2 release. So as the general highlights, so we published a new minor version of the Redfish specification. We added language in the spec with regards to how to handle atomic password changes. And we also added in a new clause about using outbound connections to kind of go through firewalls to remote clients that can't otherwise communicate directly with a Redfish service. We also added some new statements to session login where if a token is required but was not provided by a user, so that's for cases where you have a multi-factor authentication enabled and you need to provide a token in addition to username and password. We did have some errata fixes in the Redfish spec. We clarified some usage of e tags for put and patch. We clarified some of the examples in our deep operations clause to show that a single post operation can have many different resources of different types within it. We also clarified that the expansion query parameter really should include the entire resource, not just pieces of the resource. We do have a new schema bundle published, and we'll talk a bit more about that in a moment. New message registry bundle. The highlight here is that there's a new message in the base message registry to indicate that a one-time passcode has been sent to a user. So if you're attempting to authenticate with a service and you need to provide a one-time passcode, this lets a user know that it was sent to some location. Within the schema bundle, we have several new schema additions. We have several to start modeling software running on a computer system, so applications, containers, the operating system itself, so showing what might be running on a computer system. We have a new resource to support CXL dynamic capacity devices. It's the MemoryRegion resource. And we also have a new outbound connection schema to allow users to configure remote outbound connections. Then we have a slew of minor updates, but some of the key things to highlight is that we added a new property in our common location object called physical address. We added in a decommission action to computer system. We added a remote server SSH keys to the update service, and for a full list of all these updates, it's all contained within the DSP 8010 release material. So let's go to our next polling question. All right, so what is your familiarity with Redfish? So we'll just give it a 10 to 15 seconds for folks to answer. It's single choice. Okay, that should be enough time to answer that question. Okay, we've got some new folks, so welcome. It's hopefully we make things easy for you to get started, and a good number of folks working for member companies. So do like to see new people getting on board and getting involved in Redfish. And afterwards, we do have a roundtable, so feel free to stick around and ask questions. It could be very educational, could be new requests. So yeah, I'd like to see more feedback. All right, so let's move on. Okay, so one of the new things that we'll be doing as part of our normal release cadence is pushing all of our schema material to a public GitHub repository called Redfish Publications. This is to provide users a method through Git and GitHub to be able to get the latest schema and registry definitions without having to download zip files from DMTF's website. And so we envision that folks will be able to reference these directly. They could create links to exact line numbers and files and be able to reference things in a much more deterministic manner, as opposed to sending over an entire schema file to a user and having them sift through that. So hopefully this should integrate well with folks who are already accustomed to Git and trying to integrate new publications within their own projects. So this repository is automatically updated when Redfish material becomes public. And so we'll be having, we have two sets of bundles in here today. It's our 8010 and 8011 contents, and it's broken down into a few directories. We have our CSDL folder for all the XML files, XML schema files, JSON schema for all the JSON schema files, Open API for all the Open API schema files, dictionaries for the RDE dictionaries, and registries for all the standard message registries. All right, so one of the first major modeling additions is adding in our operating system container and application models. And so these are new resources that were requested by the Open Process Automation Forum to better describe the types of software running on various computer systems in their environment. The operating system resource contains information about the operating system running on a computer system. This also includes all the virtualization engines that might also be running. So what types of virtual machines or container engines are running. And then you have an application resource that represents a given piece of software running on a computer system. You have your container image resource to represent a container image that might be in a computer system's database of what types of containers it can launch. And then you also have the container resource to show a live instance of a container that's running on a computer system. One thing to note is that with how containers can be configured, containers can be networked to other containers on the same system. They have their own virtual Ethernet interfaces. And so containers have their own Ethernet interface collection to represent that internal network connectivity. One of the things to note is that we've also hardened the computer system model a little bit to better describe virtual machines within the model. So a computer system traditionally represents something physical, at least what's seen in many shipping products, but there is a system type of virtual in there. We are further kind of hardening that usage to show that, if you have a virtual machine running on a computer system, you represent that as a computer system in and of itself. But what was missing is that we didn't have links to show which virtual computer systems are being hosted by which physical ones. And so we added some new links in computer system to express that relationship. And so looking at our bubble diagram of how all this looks together, we have our system collection hanging off a service root, and we're showing two systems. We have system 1, which has its own operating system, and we also have VM6, and there's a relationship between the two systems to show that one is being hosted by the other. VM6 also has its own operating system resource with its own collections underneath that. So you have a set of applications that are running on the operating system, a set of container images showing the images available to that system. And then you have a set of containers showing live instances of executing containers and how they map back to the images in that container database. And then we also show container 2 has its own Ethernet interface collection with one interface exposed. One thing not shown is that while VM6 is fully fleshed out with its subordinate resources. System 1 could have that same type of modeling. It's just not shown here for simplicity. The other, so one of the other new additions is creating a concept called Outbound Connections. And this is to address a use case where you might have some internet-based application or other cloud type of service that needs to monitor Redfish-enabled equipment, but they don't have direct access to be able to create an HTTP connection to the Redfish service itself. This is typically because you might have a firewall that's preventing any external traffic or inbound connections coming into the a data center unless someone opens up a whole net firewall. And so the typical pattern that other devices use to alleviate this is to create a WebSocket out to the cloud-based service or other type of internet-based application. So that way you can avoid having to configure firewalls within your infrastructure. And so what we do here is we created a new resource called Outbound Connection to standardize how a user would configure their Redfish service to create that type of WebSocket out to out to an internet-based application or cloud service. We also represent this with a Redfish session as well once that connection is established. So we did register a new WebSocket protocol with IANA. It's just simply called it's a sub protocol of Redfish. And so when this outbound connection resource is created, the Redfish service will initiate the WebSocket connection out to the requested destination. And then that client on the other end of that WebSocket can use that same WebSocket tunnel to initiate Redfish requests. So all the Redfish encoding is done through that WebSocket. And so kind of the workflow that you see here is that an administrator within the firewall would first configure the Redfish service to establish that persistent WebSocket going out to the external user. As part of that, the administrator would need to give the URI and any other sort of required information to make that connection. Maybe there's certificates that they need to install to verify the external client. Maybe there's authorization headers that need to be provided as part of that WebSocket request. All that's configured in the Outbound Connection resource. And then once that's created, the Redfish service creates the WebSocket connection out to that external client. And then that external client through that WebSocket will tunnel Redfish requests over that WebSocket. So once that socket is made, you can then have everything initiated by the external client to send in a Redfish request, and then over the same WebSocket get back your Redfish response. Okay, and we'll turn it over to Jeff to go over the other changes.
Right, thanks, Mike. So there's a few more new pieces. These are sort of smaller topics, but can be critical for some users. We had several requests for additional password handling mechanisms. The first was the use of a one-time passcode for support under multi-factor or two-factor authentication. So the Redfish spec already supports multi-factor authentication with several external authenticator mechanisms. This one allows for the service to produce its own authentication challenge and deliver that to the client. So the one-time passcode support it works by having the user attempt to generate a session, a Redfish session, that will be denied, and the service will now return a new message defined that Mike mentioned at the top here. So there will be a message in that response, that explains the one-time passcode has been sent, and then the service will then send via email, all using the pre-configured one-time passcode delivery address in that manager account for the user. They will send an email using the SMTP settings also available in the service already. So that delivery occurs, the user then retrieves the one-time passcode from that email, and then uses that OTP value as the value of the token property when they then attempt to create a Redfish session. And then once that has been received and obviously validated, then the session gets created as normal, and then they use the rest of the normal Redfish authentication headers and so forth to process normally. The other password handling mechanism was a desire to have an atomic password change. The current mechanisms allow you to change a user's, change your own password, or for administrator to change another user's password, but you do not have to provide the fact that you have already authenticated and have an active session was deemed to be a good enough answer for making that request as a valid session. However, some clients want to make a more robust version of that and make that an atomic action, meaning that you have to provide both the current password and the new password, as all together to ensure that that you weren't subjected to a man-in-the-middle or some other kind of security fault. So there is a new action called change password under the manager account, and there are two required parameters that you must provide both a password, that's obviously the new password that will be applied to that account, and then the session account password, that is the password that is associated with the account that is making the request, or the one that is the active session. So this allows for either the user to change their own password because they will be logged in as theirself and will have their own session, or an administrator changing the password on behalf of a user would use their, they would be logged in as that administrator's account and that session. So that process can be performed for either just routine password changes. It can also be used for an initial password change that may be required of the service, and that is there. You'll find the password change required flag set in those manager accounts in those cases. And then lastly, part of that is there is also a Boolean property called require change password action on the account service, and that is a way for the administrators and the service to basically require you to use this atomic password, and in that case, a simple patch to the password property in the account service will not succeed. One of the other areas of improvement is enhancements to our location object, which location is used widely throughout the model as a consistent way to locate where in the world this resource is. And if you're not familiar with location, it divides that process into three categories of effectively, where are you in the world, where are you in the room, and then where are you within a chassis. So things like part location allows you to find, DIM socket 1 versus DIM socket 8, but also it also is there for helping to figure out that this machine is located, in Texas and not in Taiwan. The physical address portion of location was based originally on the contents of RFC 5139, which is a long-standing way to describe physical addresses. It is, I can't even say how many decades old that RFC is, but we were not looking to redefine things, so we took that as is. But over the decades, the usage of this data has changed dramatically. We don't actually expect folks to divide up the address into these little tiny pieces of cardinal directions and substreets and et cetera, that were necessary to be able to describe that kind of in a database terms. What we expect folks to do with this information now is probably to copy it into or submit it as a parameter into a map API or some other API that is going to translate that into into GPS coordinates or other usage. So the individual partial address properties meant that it was very difficult for us to specify to implementers what fields should they actually support, because providing the 20 or 30 so partial address pieces is really a cumbersome thing especially for small devices and firmware, and reserving storage for all those things just doesn't make sense. So all that said, we have replaced that postal address, which was that portion of location that was involved in that from that RFC. We've replaced this with a new physical address. So that has a very small, in comparison, number of properties that builds up really the physical address in a small number of pieces, and trying to get this to a point where both humans and client software that's trying to sort things by location, can both have their needs met without having to have dozens and dozens of properties that may or may not, ever be utilized. So you can see here that this new object contains one line for street address, and the example I've given here, there's an apartment number or a suite number, as well as a lot of both an address and a cardinal direction. So that is all provided really as something for an end user, but we expect that if you needed to submit this to some map API that for deliveries and so forth, that it will absolutely be able to parse these things, break them apart, and all on its own. We did break apart though the rest of the address structure. So you see we have city and then state. We did try to at least give the naming here so that for folks outside the US, the whole rest of the world, that try to give some context there, and then country and postal code, and these are all intended to be free-form strings available for end users and should be generally spelled out. The issue that we have with parsing these things is that country, United States, that could be United States, it could be US, USA, United States of America, lots of variations, and this causes problems for folks trying to do sorting and string matching. So what we provided instead is, and luckily ISO already has the definitions for these things, to give a country code that's a hardened abbreviation for every country, and then also ISO also provides what's called the subdivision code, and this maps to the area within the subdivision, the state, the province, the parish, all of those possible subdivisions of a country, but provides those with a code. So these two properties then become useful for software trying to map these locations. Whereas the street address, city, state, country, and postal code, this is all available then for an end user or for humans to consume, or to be combined and shoved into some other mapping API that will know how to make heads or tails of all that. So we hope this will provide implementers with a good impetus to actually implement this, because we want folks to have these physical locations placed in their hardware, in their configured hardware, so that we can do more sophisticated queries for location-based services, and other reports that folks running data centers would like to be able to create. So we would encourage anyone implementing this new physical address to please support all of those fields, all of those properties, so that we have some consistency and interoperability. So one other clarification that we've made in the model is that over time, as the model expanded in both breadth and depth, one of the areas that was added was a collection of PCIe PCIe devices. So there has been now for several years a collection of PCIe devices under the chassis. That the intent of that device resource was to be either a device or the empty slot that could contain a device. And so as that was fleshed out, the other resource that we had defined to just describe the PCI slots and not necessarily the contents as a fairly static resource. That's what this PCI slots resource was. So since we have the collection now available of PCIe devices, and that can contain the slot information, it no longer makes sense for us to keep around this PCIe slot resource. It becomes duplicative and really not what we want folks to implement anymore. So we have deprecated that resource. The information is therefore available in the PCIe device collection, and we did go through and have to add a few pieces to make sure that 100% of the slot description information is available, within that PCIe device. And I've highlighted some of the things there that were added recently in support of that. Okay, now we'll get into the rest of the minor revisions, and I'll go through these very quickly. There is a full full changelog in the README that's included with DSP 8010, which is where all the schemas are kept, and then obviously the absolute details are within the individual schema files themselves. Starting with account service, these are all items to supporting the new functionality that we've already talked about, between the one-time passcode, the require changed password, both the action and also the links to the outbound connections to show what's going on. There was one addition of the email attribute in the search settings. That was to make sure that you can that folks using LDAP instead of local accounts, that we can map the email address, so we can locate the email address in the LDAP records to use for one-time passcode. Action info. When parameters have been added, especially for OEM actions, there is the need to explain to a user what those allowable values mean, and so we've added a property that contains an array of description text, so that you can describe, especially on OEM actions and parameters, what the allowable values mean. So it'd be that allows end users to discover and understand what those parameters mean without having to find OEM schemas. Certificate added a number of certificate usage types to cover new pieces of new specifications that have been released. Chassis added a new object called doors. This is another area where we have tried to map what would have been previously in previous specifications done as very generic, discrete sensors or simple Boolean, 1-0 kind of open close, dry contact inputs and so forth. But in Redfish, we want those things to actually be rendered as properties that have been fully decoded. So what you will see in the doors object within chassis is describing, well, physical doors, panels, whatever you want to call them. Once again, terminology and the English language limits us to interoperability. So within doors, there's actually two doors defined for now. There's a front door and a rear door. Each door then has a couple status properties to showing that the door is either open or closed, that the lock is either is either locked or unlocked, and then giving some, I think there's a name in there as well to help folks map that into the real world. And obviously, as we just said, the PCI slots resource, there was a link there, so that's also been deprecated. In computer system, this is all covered as Mike covered in the new operating system and the applications and so forth. So the hosting computer system is in support of that. Um, the one other action that was added, this is trying to be an easy button for end users to perform a decommission process. So the decommission action will do a best effort to do all of the erase and reset to defaults for everything about this computer system. This was intended to make an interoperable way for someone to decommission a system without having to know the specifics of that make, model, and vendor as to what types of things could be erased and cleared. So this is just effectively what you would the same thing you would tell a human: go decommission that system, do whatever it takes to make that happen, and then let me know if you run into a problem. And so that's the intent, and we hope that folks will bring in additional items like this, where we want to get to interoperable functions that, while they may have very different processes within the implementations, the end result is the same. I have decommissioned this, erased all the user data, and made it ready for either recycling or repurposing. And I'm moving quickly now as we get to some of these other pieces. The memory region, that's the links to new schemas. We added some redundancy support. Then that was as a direct result of feedback from cooling system vendors. So cooling unit, and you'll see another one as well that shows the ability to have both redundant cooling units and also redundant connectors to a cooling loop. The memory regions, again, support for that for CXL. Little minor things like native command queue depth in DriveMetrics and routing scope and Ethernet. As I already mentioned, there the email attribute in external account provider for LDAP. Resolution is a text added to event. This is the same that was done in log service previously. So trying to provide guidance to end users as to, hey, this is an event, this indicates some issue or problem, and here is some recommendation coming from the service to say what you can do to resolve that. The secondary speed percent, this was a challenge that as we didn't want to make a lot of weird combinations of gear, but we also don't want to make folks crawl through a lot of extra hoops for things that become commonplace. So there are many redundant or just performance-oriented fans, especially in very small chassis like 1U high chassis, that will double stack a fan, where you effectively have two fan units that are welded together, and so they act as a single unit. So they are not individually replaceable, but you may actually get a report from those units to show that both of those fans in that contained unit can operate independently. So we added just a secondary speed percent to the fan, so that in that case you can still model that unit as a single fan entity that just happens to have a second fan inside that only need to provide the speed, because everything else is all part of the same unit. A remote server hostname is part of the SSH support as we continue to broaden that usage out. CXL has its own log format, so that will be an opaque piece for Redfish, but you can create and retrieve the CXL log using one of our log service and log entries. The manager account, this was some minor changes as we realized that when we were doing the one-time passcode support, that we didn't have the contact information for that user. You had the user's name, but we did not have a place to drop an email address or a phone number, so those were added as well. In memory chunks, those are the links supporting the new memory regions. PCI device, as I said before, this was some additional cleanup to ensure that we had full coverage from the PCIe slots resource that we were deprecating, and there's some dynamic capacity pieces for the PCI device, but that's part of the CXL work. I've already mentioned the PCI slot deprecation. Port, this was a small error that we had as we migrated a network port to the port, the more generic and widely used port resource. We mistakenly created copied the property enabled from network port because it didn't exist. We found later that effectively duplicates the property interface enabled, which was pre-existing in port. Since interface enabled was already there, we deprecated that enabled property because it is truly duplicative. Quick add to a port metrics for a PHY reset count. In resource, this is where the physical address work that I already talked about. That's where that is located and is referenced in throughout the schema. And I don't think I mentioned, but we did deprecate the postal address object, in favor of this new physical address, thinking that this should our recommendation would absolutely be to use the new physical address rather than adding support for things under postal address. There were some links was just an OEM request. Session, this is adding the support for the outbound connection that we talked about earlier. Software inventory, this is some additional details to give a release type to say whether this is a production release, an internal or prototype, to help folks get that the context of what that release was, what version is truly installed, and are you running production code or not, or pre-release, and then the physical context that for things that may be a piece of software that only addresses a portion of a resource. That's a way to give that better granularity. The cooling loop redundancy I mentioned already. In thermal metrics, so this was a request from some work going on in areas of sustainability, especially as we got feedback from the Open Compute project. This is trying to determine new metrics for unit power efficiency, and so thermal metrics, adding power and energy readings, that is for the thermal subsystem. So basically the summary of power being used for fans or liquid cooling pumps, effectively the overhead of running a computer system, but not that is not power involved in the actual work provided by the CPU and memory complex. Thermal subsystem, this was also requests. We added the cooling redundancy and pumps and leak detection inside to have those both inside a chassis as well as in the larger cooling unit pieces. Trusted component, just there was a miss and needed the owner in the links to show who is owning that, obviously, and then some additional SSH support for the update service. So in conclusion, just wrapping up just a reminder that if you're new to Redfish, the way to learn as much as you can about the schema and the data model is from the guide documents that we produce for every release. Rather than trying to wade yourself through the actual schema files themselves, those are generated into more human readable documents with a lot of material up front as introduction and hopefully explanation of some of the common pieces. There are two varieties of that. The data model specification, this is the one really targeted at service developers because it includes all of the normative language to explain what has to be implemented. The Redfish resource and schema guide is a more abbreviated version that doesn't get into all of that normative, more complicated language, and is really meant to be just the information as an end user. So if you're a consumer of the Redfish data, start with the resource guide. If you're a developer, read the data model specification. Same goes for the message registry guide. This takes all of the standard messages and provides those in human readable form. So if you are trying to decode a message that you got from a Redfish service, this is the easy way to look it up. All of the standard resources. And lastly, just if you are truly lost, or if you're trying to create your own OEM extensions to Redfish, take a look at the Redfish property guide. This is effectively an alphabetical list of every property defined across every schema, so you can see what we've already defined, and if you need to either figure out where something belongs or what you should call something, you can see what we've already what terms we've already used. So lastly, and then we continue to find folks that are not aware of the conformance and the conformance tools, and really just the open source pieces that we have available from the DMTF. So let's pop up that polling question while I talk about these. So what are shown here on the screen are 3 test tools that are available on GitHub under the DMTF's GitHub organization. They provide ways for you to test or validate a Redfish service. The service validator is the one to start with. This checks the service for conformance to the Redfish schema to make sure that the payloads meet the requirements of the schema and everything is spelled correctly and so forth. So if you're having a problem as an end user and don't understand why something is not working, run the service validator against that machine and see what it comes up with. It can be very helpful for explaining explaining bugs to service vendors. The protocol validator, this is testing all of the HTTP operations and a lot of the nuances of that spec that are trying to be tightened by the Redfish protocol. So again, very helpful if your software is not working, to check to make sure that the service conforms to the specification, and hopefully that helps you to get some to point some fingers for blame. And then lastly, the interop validator. This is used with interoperability profiles to validate that a machine's implementation meets the requirements that are laid out by a profile. So with that, I had the polling question up. Are you aware of, and do you use any of those open source tools that from the DMTF? So let's take a look at that answer. And good. So it looks like we had folks that probably have been on these calls before and are aware of that. And I see that we still have about 1/3 of the folks were not aware of that. So again, we try to make this. We want to make sure that these tools are well known. But the DMTF organization on GitHub has these test tools, but also libraries, the tackle box that gives simple scriptable command sets to utilize the Redfish interface. And so we encourage you to do that. If there's anything you can suggest to us to help a better outreach, to make sure that the folks are aware of the tools and the libraries and all that support in the ecosystem that are available, we're all ears. Please give us that feedback. So with that, we'll move to Q&A. If there are any questions here, we can take them in chat. And I'm sorry, I apologize. We don't have the ability to take voice questions, in this webinar format. If you would like to just ask a question, as soon as we finish here, we will move to the separate meeting for the open discussion in our Redfish roundtable. And I'll give folks just a second if they actually wanted to type any questions. If not, that's not a problem. We will take them in roundtable. All right. Well, while we're waiting there, we do have a question. Okay. So the question is, how are we authenticating the user prior to WebSocket connection, or just the header validation of the WebSocket?
I can take this. So
go ahead.
It depends on how you configure that outbound connection. You could do mutual TLS authentication, so that way you install the certificate, the identity certificate for the remote user. And as part of that WebSocket handshaking, you do that initial TLS handshaking, but prior to making the WebSocket, and you can do a certificate comparison to make sure that you are a valid and trusted user. Other than that, it is just through header validation. At least that's what's covered in the standard today, is through authentication headers. You could pass in a JSON web token potentially, or maybe you just have a simple username and password or some other type of identifier, but it's pretty open-ended for what you put in that configuration.
Good, thank you, Mike. That was a more detailed answer than I was going to give. Okay, seeing no other questions, let me just conclude with the how to get involved in Redfish. So obviously you're here, so you're aware of the standard. Hopefully are able to either implement it or use it. These are the resources that we have available. Everything really starts from the Redfish developer portal. So if you're unsure of what information is available, please go to redfish.dmtf.org. We have links from there to everything else that the DMTF provides, so you can get to all of the rest of the resources from that. So if you remember one URL, that's the one to get. The standards, the actual specifications, all of our white papers, those are all available at the DMTF standards Redfish page. We do have a user forum at redfishforum.com where you can ask questions. Mike and I and several other folks, we do review every post on that every week and try to get an answer for all of those. And so please keep those coming. We get lots of good questions and additions and clarifications. A lot of things come from those forum. If you have a proposal or something that you would like to see added to the specification, those are all welcome. There is a process to go submit that, and that process does require you to go set up an account, but that is all free and just self-contained. It doesn't sign you up for a bunch of other stuff, but that is necessary so that we have make sure that we get clear intellectual property rights and copyright and so forth. But feedback is encouraged and welcome through the DMTF feedback portal. And lastly, if you are a developer or are heavily involved as either a producer or a consumer of Redfish data, we encourage you to get your company to join the Redfish Forum. Come on in, the water's fine. As a standards body goes, we're really inexpensive, and we can guarantee that we would save you weeks of R&D time just by getting your questions answered, very, very quickly, and any of your concerns, incorporated or added to the specification as needed. All right, with that, I want to thank everyone for their attendance today. I see we had folks that have followed us all the way through. So in your chat, you have the link for the Redfish Roundtable, which is a separate Zoom call. And we will end here, and we will join you over in the Roundtable. Thank you, everyone, for your attendance today, and hope you have a good rest of your day.
Thanks, everyone.